This Thursday, December 6th, from 1 to 3 p.m. Eastern, is a fantastic online summit and PD opportunity about personalized learning. I'll tell you more at the end of the show how to join the conversation. I'll be co-leading with Text Help and the other Ed Week participants. This is Hour of Code Week starting December 3rd. And today we are kicking it off with 5 ways to help kids of all ages code. Episode 396.
The 10-Minute Teacher Podcast with Vicki Davis. Every weekday you'll learn powerful, practical ways to be a more remarkable teacher today.
So today we're talking with Canadian educator Brian Aspinall, an author of Codebreaker 15 plus ways to get started with coding. Brian, you've prepared for us ways that we can help kids of all ages code. So for our first way, could we start with kindergarten?
Absolutely. Good morning. I think I get asked a lot about low-tech activities, particularly with our 5-year-olds, and there's a lot of opportunity to integrate coding into math programs, talking about something like geometry or location and movement. I usually suggest having young people come up with a pseudocode with their teacher in the class and then program each other, sort of a kinesthetic activity. Call it the friend bot, right? Can you move your friend around the classroom from point A to point B using directional language in a sequential kind of a manner, like a recipe?
Oh, fun. So I would have my friend and I would say, step forward 2 times.
Exactly right. And then, the teacher has an opportunity to scaffold and differentiate that activity because you can place obstacles in the room strategically.
Oh, that's fantastic because you could teach that and then you're ready when you go, on code.org and play Puppy Adventure or whatever. You've actually taught some of those concepts, haven't you?
Exactly. Yeah. So it's not so foreign to them when they actually jump on the devices.
Okay.
Actually, and that's a good segue to, moving into the grades, our primary friends there.
Yeah.
And like grades 1 to 3, I totally think the tutorial approach is fantastic. I do believe that we have to teach kids the learning to code space first, but ultimately we want to push them into the code to learn space. So after using the tutorials on websites like code.org or even the Scratch website, we have our young friends jump into those sandbox tools like Scratch Junior, where they can create content to demonstrate thinking and understanding in other content areas.
Awesome. Okay. So you want them, to start with some tutorials. They learn this space and then they start using coding to actually learn the content. That's what you're saying.
That's exactly right. I mean, we
Awesome.
learn to spell so that we can make words, so that we can make sentences, so that we can write poetry. And so coding's no different, right? We have to do those tutorials, the learn to code space. There's not a lot of opportunity for critical thinking, so to speak, because it's more of a game. You follow each step by step and do the instructions. And once you have that understanding, then you jump into that blank canvas space with tools like Scratch, where you, like you said, you create content for learning in other subject areas.
You start sandboxing. Okay. So what's our third is going to be the upper elementary ages. What do you have there?
Upper elementary. Here in Ontario, we would define upper elementary as grades 7 and 8. And I think you refer to that as middle school in parts of the U.S.
Oh, we do. Yeah. So let's say grades 4 through 5 or 6.
Yeah, grades 4 to 6. Well, see, it's like layers of a cake in my mind. And so we can continue to add layers to the experience. And so some students in your class in grade 3 might be learning to code in that open space like Scratch. But as we progress, we've got a bit of a continuum now. We can start adding peripherals to the experience. We can bring in other hardware devices like Makey, for example. And I know that there's a lot of grade 6 students all over the world that study electricity in grade 6. And, it's a great opportunity to look at building circuits in that physical space and offers a blended learning experience. So you're interacting with physical objects while controlling the content that you've programmed in those sandbox tools like Scratch.
So those who don't understand Makey, because, if you've been to ISTE or any other conference, you've played with those, but just give us a brief description so folks can understand what is Makey.
Of course. So Makey is a tool that was crowdfunded. It was kickstarted out of MIT, which is where Scratch comes from. And it's a keyboard interface that plugs into your device using USB. And it allows you to do keystroke inputs with physical objects by alligator clipping things like bananas. So if you alligator clip a banana to the Makey, when you press the banana, the computer simply thinks you're pressing the space key.
Okay. So it's just a simple interface to kind of help us. And I love it because it bridges the physical world with the electronic world and shows us how we can program things and can teach so many things. So that's fantastic. Okay. So our fourth would be what in the U.S. calls middle school, but you call upper elementary, which would be, say, grades 7 and 8. What can we do there with coding?
Yeah, in the grade 7 and 8 space, I think there's lots of opportunity to integrate some of those syntax-based languages. We've almost come full circle now. We have to go back to those tutorials again, but it might be like teaching a grade 7 student to write code in Python, for example, which is a very forgiving syntax-based language that doesn't have a lot of rules, but it's an opportunity to do some more advanced programming because you're not limited to what's provided by those block sort of environments. And you have an opportunity to explore like real industry type programming languages that are actually used in the real world.
Can teachers find resources for teaching Python? Because some teachers may say, hey, I want to teach this, but I'm a little nervous.
Yeah, no, absolutely. There's a ton of stuff out there. I've actually written a course. I have a Python course available on my blog I can share at the end of the show. But there's a ton of resources available out there. I'm a big fan right now of the Microsoft Make Code platform that allows teachers and students to program hardware devices like Microbit because it offers the block language, but also shows you under the hood. So you can see what Python and JavaScript look like. The Google Blockly allows for the same thing. You can see what the block languages look like in different syntax languages.
And that's fantastic because you can literally build it by snapping the blocks together, kind of like we do with the very young kids at code.org. But then you hit a button and you can see what code you actually wrote, correct?
Absolutely. Yeah. And you can edit it too. You can debug it. I call it the looking under the hood, if you will.
Excellent. Okay. So now we're looking at high school grades 9 through 12. What should we be doing there?
Well, we're pushing them back into the sandbox. They understand syntax. What can we do with Python that will allow me to build a project that's going to change my community right here in my own backyard? We're talking, high school students that are on the brink of going into post-secondary or even the workforce. So what can they do with the skills they've developed, in that K-12 space, from block to learning syntax to actually using syntax to create projects and find solutions to problems that might be affected by their school or their community.
So as we prepare for Hour of Code, Brian, do you have some encouragement for teachers about, why this is important and what we should be doing?
Yeah, absolutely. It's become known as Hour of Code Week. It's actually Computer Science Education Week. So there's lots of opportunities for teachers to just jump in. It doesn't even necessarily have to be directly with code. I always suggest having teachers have their students, ask grandma and grandpa for old VCRs and have a Tinker Tuesday. Take things apart, inquire about how they work and what makes them, what makes the gears spin and all of those pieces, so that when you're actually programming, you have an understanding of how the hardware is actually interacting with the software you've written.
So we've gotten 5 ideas to help our kids be code breakers, code makers, and play with code. It's just such an important way of creating and inventing today, because we don't want kids to just be those who play a game. We want them to make a game or make something useful for our world. Thank you, Brian.
Thank you so much. I mean, you summarized it up right there. And to quote Mitch Resnick, we don't teach students to read and write with the understanding they'll all be professional authors. And we would love it if they were, but that's not the reality. And coding is no different.
I've written about text help before in their awesome Read Write toolbar and the Equatio Math Helper for Google and Microsoft. This Thursday, December 6th, from 1 to 3 p.m. Eastern Time, EdWeek is hosting an event all about personalized learning. I'll be co-hosting a panel conversation on how I help kids learn how to personalize their own learning, how we can differentiate instruction, and we'll have an old-fashioned tool speed share at 2 p.m. in the room. Even if you can't attend live, you can sign up and review the links and transcripts later. Get ready to talk about personalized learning this Thursday from 1 to 3 p.m. Eastern. Just go to https://text.help/coolcatteacher and sign up to join the conversation.
Thank you for listening to the 10-Minute Teacher Podcast. You can download the show notes and see the archive at coolcatteacher.com/podcast. Never stop learning.